I am Holly Rutenbeck. I am the chair of the Buildings and Grounds Committee here at St. Sebastian. I'm an alumni of St. Sebastian. I have 2 kids that go to school here. I'm a parishioner, and I'm also a licensed professional engineer. As the chair of the Buildings and Grounds Committee for the last 2 years, we have been putting together a master campus restoration plan, which would have been mailed to you if you are a parishioner, and was also available through a link in the school newsletter the last couple weeks, so you can always download it online. The first item that we have listed on that master campus restoration plan as our priority is the school facade. And so the purpose of this presentation this evening is to go into a little bit more of a deep dive of how we came to the recommendation that we have inside of that master restoration plan for the entire campus. We'll hold all the questions until the end of the presentation. And with that, I'm going to kick it over to Rocky Marcoux, one of our parish trustees, who is going to go over some of the other items that are on that master campus restoration plan. He's going to just kind of go through that briefly so that we can save time for our consulting firm to be able to go through their presentation, which is going to talk about all of the different alternatives that are going to address the issues that we've been finding around the school.
Well, thank you, Holly. And on behalf of parish leadership, we would like to give Holly a huge thank you. She has been the chairperson of our Buildings and Grounds Committee, and we want to thank everyone that served on Buildings and Grounds, but in particular her leadership, both from her professional standing as an engineer, but also as an incredible volunteer. She has brought great leadership to this and has really pulled our team together. So thank you very much, Holly. And Brian, if you could get the lights. We'll start with our first picture, of course, is the corner of Washington Boulevard and Hawley Road. And it's the most beautiful, we believe, the most beautiful church on the west side. It certainly is a gorgeous example of Gothic architecture with some American influences as well. This church was built in 1929. We actually laid the cornerstone on October 8th of 1929. The great stock market crash happened 3 weeks later. Now think about that. We built this church, and I say we because all of us that belong to St. Sebastian's Church today really rests on the shoulders of the folks that came before us, generation after generation, each building on the foundations of the generation before. And this church originally was planned to come out of the ground in 1929. And as I said, the Great Depression happened, and people never blinked. I'm sure they had their moments, but this was kind of our 1929 moment. When you think about taking on incredible challenges, the fascism was on the rise in Europe, as well as the world economy literally being in tatters. Yet this congregation on the west side of Milwaukee pulled together an amazing structure. And it's built on top of the church hall. The church hall was one of the original worship spaces. It was completed in 1926. So during the construction of the main church, we worshiped in the church hall. This long list that Holly had alluded to is available on the website. It also was mailed by Father Peter Patrick. And we'll talk a little bit more about that at the conclusion of the presentation. There's a slide that shows the scaffolding around the original church in 1929. And in 1930, the church was dedicated. So this slide is about probably late summer of 1930. You can see the beautiful stained glass windows are already in. The bell tower has taken shape. The church was built with a standing seam metal roof. Portions of it were zinc, and we believe that was due to the Great Depression. That was a cost savings. So what didn't face the street was zinc. What faced the street was copper. This is the 1960s school. We'll talk about that a little bit later. This is the 1960s convent, and this is the parish house, which actually was built just a couple of years prior to the start of construction on the main church. In 1980, there was a major renovation inside the church to get the church interior consistent with Vatican II norms. So there was a thrust placed, the altar rail was removed, there were a number of other changes. The interior of the church was painted. The failing standing seam roof, however, was not replaced with another standing seam metal roof. It got a 3-tab shingle roof. which is basically a 20-year roof. It's what you'd put on your house. So when we did Giving Faith the Room to Grow, which was in 1999 through 2001, we took the 3-tab shingle roof off. We also took the original standing seam metal roof, and we replaced it with a brand new copper standing seam metal roof. We replaced all of the flashings, just a gorgeous roof. Most institutions have a real issue with their roofs. That's the big ticket items that people put off. In our case, we're in good shape. The main church roof was replaced in 2002. That copper roof should last 75 years with some intermittent maintenance. School roof was replaced completely in 2014. The parish house has multiple roofs. There's 3 different roofing types on the parish house. We'll deal with that on an as-needed basis. The gathering space roof, however, which is what you see here, needs to be replaced. It's about almost 25 years old. So when we did Giving Faith the Room to Grow, and the reason we didn't do a more expensive roof, this is a single-layer EPDM roof with a ballast on top. We originally were planning to put 2 additions above, 2 levels above the multi-purpose and faith formation rooms. It would have given us 4 additional classrooms that would have connected into the stair tower here. We did not build those classrooms because the budget was about $3.4 million when we opened bids and started construction, so we said that would be something perhaps in the future. The parish never executed on that, so that's why that roof was probably the least expensive roof we could put at the time. We just didn't want to tear it off if we were going to put an addition on. So now we do need to do those repairs. This is the cupola over the main roof. This, of course, if you're not paying attention when Father Peter Patrick is giving his sermons, you can note above the altar some of the deterioration here. There's water coming in here. We intend to resolve that, part of the process of the list that Holly spoke of. You can see Brian Kirkpatrick here, our Director of Maintenance, that gives you some scale as to how big this cupola is. We have lightning protection. Aerials are on the chimney at the school, as well as on the bell tower, and at the ends of all of the copper roofing. The church was actually hit by lightning in the mid-90s. It actually reduced the cross by 3 feet. And the chimney, a good portion of it was blown apart. If you look at the chimney carefully, there's 2 different colored bricks there. The chimney needs to be tuck pointed, but we put new boilers in that don't require as much draft, and we no longer use the incinerator. So we will lower the chimney and tuck point the balance of it and then reinstall the lightning protection. The main boilers were replaced in 2012, as I just alluded to. Another big piece done and accomplished, and these have pretty much paid for themselves through the energy savings, the gas savings. There was just tremendous loss that we had going up the chimney prior to that. The school put on its own fundraising campaign specifically for the playground, and that replaced the playground from 2001. And of course, this is very, very highly used and very motivating for our young folks at the school, as well as folks that come in on Sundays as well. You see folks out there playing. The 2022 Stop the Auction actually allowed us to completely refinish the floors in the parish house dining room, as well as in the living room. So we now have places in the parish house which Father can host. Maybe somebody's coming over at a moment of grief. These are more home-like spaces, and this was raised from the 2022 Stop the Auction. The 2023 Stop the Auction will do improvements into the school cafeteria. Speaking of the cafeteria, it's been completely relit with new LED lights, as well as the church hall and the gymnasium. All of that was done in the recent past. We intend to relight all of the classrooms as well as part of our master campus restoration plan. Last time the church was painted was 1981. If you look at it from a distance, not too bad. You look up close and personal, not so good. This was the damage that was from the bell tower. We did do that. Holly felt that we needed to put the finishing touch on that when we did the bell tower restoration. So we did replace the missing pieces of plaster and then repainted it. But the balance of the church is badly in need of a paint job and plaster repair. We cannot do that until we stop the water from the water infiltration that's occurring. We have water coming in through the stained glass windows, as well as water coming in through the limestone itself, similar to what we had on the bell tower. If you look at the window beyond the altar, that's the St. Sebastian window. These clear story windows on either side were also completed and completely redone in 2010. When we took these windows apart, we had to replace the tracery. Now the tracery is basically the framing. The mullions it's all wood. It was all rotted. And when we had originally thought we could save it, we took it apart, most of it came apart, literally, as we disassembled it. But the St. Sebastian window is in wonderful shape, and we have, of course, looking to the window in the west transept, as well as the windows in the east transept, all the windows looking back up towards the choir, and then, of course, the balance of our stained glass. We have some of the finest stained glass windows, certainly in the city of Milwaukee, as well as in the state of Wisconsin. And stained glass plays a pivotal role in the history of the church. In medieval times, in the Middle Ages, when cathedrals started to be built, stained glass replaced mosaics in windows. And the reason for the stained glass, they tell stories. They tell Bible stories. And back then, a lot of folks were illiterate. They couldn't read the Bible, nor was the Bible, in terms of reading it, encouraged by the church. It was up to the priest to interpret the Bible back then. So people learned, parishioners learned their Bible stories from the scenes that are depicted in the stained glass. It was a mnemonic device, and it worked very effectively. So fast forward from the Middle Ages, the beauty of the stained glass, of course, is something that everybody wanted in their churches, and that found its way into a lot of modern American churches, or at least churches of our vintage. The problem we have with our stained glass is it has multiple issues. This is, in the circle, you see is canted. It may not be able to see it clearly on the slide, but it's actually at an angle. There's a deflection here. What's happening is the lead cames, which hold the glass together, are under pressure now because some of the window weight is coming down, because there's a failure in some of the structural pieces, the steel. In some cases, these are rods. In other cases, they're actual frames. So that weight is bringing down that window to a point where there's a deflection. This is probably the worst case. You can see it for yourself. Most of our stained glass windows are not accessible. This one is actually pretty accessible. It's in the choir loft. And there's a big radiator here, which is also adding to the issue. You have heat coming up from the bottom, and then you have from the outside, because it's a south-facing elevation, you have a significant amount of sun. This is the tracery I spoke about earlier, the framework. You can see all of the wood is in really bad shape. It's taking in a lot of water. It absorbs water like a sponge. This exterior glazing or window treatment actually is designed to protect the stained glass and also to keep water out. It has failed. All of its seals have failed on the perimeter. The glazing has failed. The tracery needs to be completely replaced. This is after a recent rainfall. You can see the water that is absorbed into those cracks. The fibers of the wood break down. You have freeze cycles as well, not as significant in wood as masonry, but it still attacks the actual wood fibers. So we're going to have to replace all of the tracery when we take these windows out, and they should look like this when they're done. This is the outside of the St. Sebastian window with all of the tracery restored. The bell tower, that was a major project by the parish, about $750,000 in 2021. And here's a drone shot. This was actually taken from before the bell tower restoration, which can show you that appearances can be very deceiving. If you look at this, all appears fine, right? You see some telltale signs of efflorescence, which is the salt that is taken out of the mortar when water passes through it and then comes back on the other side and evaporates. These roofs here look to be in fairly decent shape. That roof from the drone doesn't look great, but it looks passable. So this was what we started with when we did the bell tower restoration. We knew, however, that despite what the drone would tell us, the water was coming in significant amounts, as well as the efflorescence within the bell tower areas. This is the scaffolding we put up on the bell tower. Very expensive, but very effective. We had a number of issues. On top of the scaffolding, significant deterioration of the mortar joints. Good news is the stone was in excellent condition. We have a combination of flat cut stone for the ornamentation, as well as some of the other cut pieces for the columns. And then we have rock face stone. It's all basically, we call it Lannon stone because it was quarried in Lannon, but it's limestone. And the challenge with limestone, or any stones and bricks for that matter, wherever you have these joints, the mortar breaks down. It eventually gets hairline cracks. If those cracks are not sealed, then you end up with water going in. Water expands when it freezes, so we call that the freeze-thaw cycle. And then we have significant crack openings that keep getting bigger and bigger each year. This has been decades of issues that were not addressed, or in some cases, sealants were applied. They may have been appropriate, they may not have, but in any event, if the appropriate one was used, it was past its usable life when we got to it. This is what we had. This is my hand literally going in between a couple of rocks. Very significant issues. This is a very good example of what we found, and then we did the process of tuck pointing. You can see on the bottom right slide. What tuck pointing is, whether you're doing it in brick masonry, it doesn't matter, or brick is masonry, but if you're doing it with stonework or brick, you basically carve out the gap in between those stones or the bricks, and you literally grind it out, and you remove the loose material, which is mortar, and then you replace it with a fresh coat of mortar, which is what we had right here. And then we did a clear sealant on it. So this was done, we probably did about 75% of the mortar joints on the bell tower needed tuck pointing. This is a slide showing the bell tower. This is the lower vault, middle vault, upper vault, and the turret cupola. The upper vault, pretty much inaccessible. We would put volunteers, as Bob Duffy, one of our parishioners, would go up there on occasion. Brian, our director of maintenance, had to scale these heights. We put scaffolding in when we did the bell tower restoration. So now Brian and our volunteers from our committee, as well as contractors, can safely access from the middle vault to the upper vault. At the top of the upper vault is a lateral cross bracing, which needs repair. You'll see that's about a $250,000 piece on our restoration plan. And then we're going to go next to this roofing area and what we call the cupola. Inside the cupola is our bell system, which is no bells at all. There are no bells at St. Sebastian's. There never have been any bells. We have loudspeakers. So what you hear that sound like bells are actually loudspeakers. The roof that was on this area right outside the cupola, we took a look at that and we said, you know, maybe this has got another 10 years left. But we've got the scaffolding up, which costs hundreds of thousands of dollars to put up, so we said perhaps we should, let's take a peek underneath. The first piece, not bad. The second piece, we just about fell in. And we had an army of ants in there, so carpenter ants. And the building's stone, almost, it's like 99% stone, but the carpenter ants will find a home. And they really were destroying this, so we had to remove all of that substrate, and the support members put in pressure treated decking below it, and then we put in a new flat seam roof, which is lead coated copper. And then of course on the top of the tower at this particular time we had an inspection going on. Chris Bowl, who's the assistant chair, or the vice chair of Buildings and Grounds, our leader, Holly Rudenbach, our director of maintenance, and the staff photographer. And we were at the top of the scaffolding, about 100 feet in the air. This is the original cross, which is at that height. This is the new cross. The original cross, as I mentioned before, had been hit by lightning, has seen a lot of wear and tear. We decided we needed a new cross. Langer Roofing, we commissioned it with Langer Roofing. Peter Patrick, our pastor, father, is everywhere, as you know. He is everywhere on this campus, and he was not going to be denied the opportunity to be on the bell tower. He was up there many times, so he really gets to where the action is. Deacon Jim with Father, and of course you remember we had a very spirit-filled moment when we brought that cross in to the church, and we were able to dedicate it and bless it, and people took pictures with it, and then we put it back where it belongs, right on top. This is a gorgeous picture, I think, looking at the neighborhood that we serve at St. Sebastian's, and it shows, our Lord's up here, right? And there's the sky, and it's an amazing thing. The cross speaks, obviously, if there was one symbol of our faith, it is that. And it was a wonderful privilege to be able to be that close to that cross, that high in the air. And the beautiful ceremony that the stewardship committee put together, CJ and Joanne and Lisa, Father threw the switch and we lit the beautiful bell tower. I'm privileged to live on Washington Boulevard, and I can see this bell tower from my backyard, and I can see it from my front yard. And it's an amazing thing. You look at it at night and you see it lit up, and it really speaks to who we are at St. Sebastian's. We are a light. We're a light to the world, as we should be. At least that's the admonition we're given as Catholics. And St. Sebastian's is a light to our neighborhood. Some questions about why we did not light the cross. The cross would have been very difficult to light, and we would have been very difficult to replace the lighting on that. Any uplighting that we would have done would have had some issues and probably would have sent a beam of light up as well. So we chose to simply light the surrounds. The cross lies in shadow. When the sun shines and when it comes up in the morning, you can see the cross in all of its glory. This is the north wall I-beam restoration. This is the St. Sebastian window. You can see the rounded tarpaulin that's protecting it. This has to be done on every single stained glass window before we actually replace the stained glass windows. And that is to expose these I-beams, which are essentially lintels that sit over above these windows. They carry the weight of the masonry that is above it to either side of the window. They've been taking on water for decades. They've been rusting. We came up with an engineered solution, cut off a piece of the existing I-beam, so we didn't have to remove the whole thing, welded in a new piece, and then put in a membrane system with weeps, flashing, so if water does get behind that wall again, it's able to come out. Landing stone gets put back in. 100% of the stonework above it is tuck pointed, and then we have these weeps for belts and suspenders as well, for water to come out. This is what the finished wall looks like. North wall coping stones. These coping stones weigh probably 250, 300 pounds. We were originally going to remove them. We decided instead, since they were still firmly adhered from 1929, 1930, we decided to leave them. And what we did is we took all of the mortar out between the stones, and instead we filled that first with baccarat, then a sealant, and then we put in a lead T-molding. After putting sealant on either side of the adjoining stones, a lead T-cap was put in, so that you can't see the leg of the T, if you will, is embedded into the sealant, and then this lead is actually pounded into the same shape as the surrounding stones. This is a process that's actually been used in Europe for actually a couple centuries, and it really actually looks pretty nice. It's a little bit of a different look. We're going to have to do the east wall. When I say the elevations, east means it faces east, north faces north, so on and so forth. The north wall, then the west wall as well. That's also part of the tuck pointing and the stained glass restoration. So the summary on that. This is the west wall of the church, with the exception of the bell tower, which has been completed. All of this will have to be tuck pointed. We'll have to address the steel lintels over all of the windows, and we will have to redo the stained glass windows. Same thing on the south face of the church, which is the front entrance from Washington Boulevard, the east edge as well. All of that has to be done, including redoing the issues with the arches. So, a couple of things in the kitchen that we, fire suppression, the school wasn't built with it. We really should have that. That's on the list. 55th Street garage apron needs to be redone. And there are probably countless other pieces to the puzzle that aren't on that list, but the things that are on the list, and it's about $5.7 million. Those are what we feel the Buildings and Grounds Committee has prioritized those by the way they should be done in terms of the order, and the items have to be done before other items are done that people may want to do, things that perhaps may look and feel good to do, but we have to do these core issues first. So I'm going to turn it back to Holly, and she's going to introduce our consulting team. And Brian, if you could just quickly put the lights on, and then we'll put them back on when we start again. One last piece on the school as we're looking at it. We talked about the 1929 moment, the Great Depression, where we actually had faith as a community to begin the construction of this incredible edifice. We also had a moment in 1960. In 1959, the city of Milwaukee was going to shut down the school for code violations, overcrowding, as well as significant building issues. And the parish rose to the occasion. It was our 1960 moment. And in 2 years, with schools still in session, afternoon and evenings, we found a home for 950 students. This school held 950 students in 1961. You think about it, put your arms around that for a bit. But that was a huge moment for the parish, and they rose to it. And then in 2001, when we did Giving Faith the Room to Grow, and we did the gathering space and a number of the improvements that I outlined earlier, that was a huge moment for the parish as well. So now we find ourselves at a similar moment, a different generation, but it's a similar moment. This is going to have to be our 2023 moment. And we need to rise to the occasion as those previous generations did. We don't get to pick when God puts us here, but we're here now. These things need to be done. We've done what we feel at the committee, a very good job of ordering the priorities and getting good solid estimates. And now we have to trust to the parish to move this forward. Holly?
All right, so now we're going to start the portion where we're going to go a little bit more in depth into the facade alternatives analysis that was performed by our consulting team, which is who is going to perform right after I'm done introducing you guys. So last summer, as part of kind of our overall vision and issues that we were finding around both the church and the school, we realized that we needed to find a qualified engineering and architecture firm in order to review the existing precast panels. So as many of you know that have been a part of the parish for years, we've been having, kind of sporadic things come up where we have to do repairs on an emergency basis. And we want to look at something that's a little bit more proactive to take care of the building that we have right now for the future of all the kids that go to school here. So we solicited proposals from the engineering and architecture firms. We received a handful of proposals, and we have selected the Building Envelope Professionals Group, who is our prime consultant on this project and is working with American Design and with McEnroe Engineering to perform the structural review of all of the facade faces of the entire school. So with that, I'm going to kick it over to you.
Great. You can get the lights again, Brian. So my name's Nathan Elliott. I'm with American Design, one of the consulting firms. I'm an architect, so I'm going to talk about some of the architecture parts of it. Eileen, who's also here, is a structural engineer, and she's going to talk about some structural components of it. And Eric is a building envelope professional who deals, in our world, the envelope, if you think about the envelope as the outside of a letter, it's also the outside of a building. So it's what has a lot of jobs to do to keep all the rain and weather out and keep all the heat in. So we each have kind of a piece of the puzzle. And so we'll try to move along briskly, but if you have questions, we're happy to talk about them at the end. But generally what we're going to do is explain, what we got hired to look at, the problem that was being, and then show you some of what we saw when we looked at the building in depth. And then the Building and Grounds Committee had a really good approach that they hired us to do, which was to come up with 3 different alternatives. One alternative would be, let's just fix everything that's there. The second alternative would be, what if we replaced the things that have been causing problems? And then third would be, after we've gone through those, come up with solutions and done cost estimates for them, is there some combination of repair and replacement that might make sense? And so those were the kind of the framework that we approached the problem with. So Eileen, you want to?
Yeah, I'm going to take over and talk for just a minute or two here because I want to talk about what the start of this problem is, like why did this happen at all? And really that comes down to structural things, and since I'm the structural engineer, we thought I should talk about that. So as many people probably know, there have been a history of spot repairs and spot things happening with the outside of this building. So the outside of the building is primarily made of precast panels. So precast concrete is what that is. It's large pieces of concrete that are made in a factory and then brought to the site and then put on a building. There's a lot of cost benefits to that. There's a lot of speed benefits to that. And it was definitely a new thing that was happening in the 50s, 60s kind of time frame. We still do it a ton now. It is a great kind of a system to use, particularly on a building such as this. So it's quite a good system, but there have been a handful of issues with the panels on this particular building. So back in 2018, I believe, the east side of the gym was replaced because those panels were moving just a little bit. And so they were taken down and a block wall was put up. This is along the parking lot area. These are some vertical panels, and there's a piece of steel that was put on that goes across there, and that's there to hold those panels against the building. And then finally over here you can see there are some horizontal pieces, and we'll talk more about each of these, but there are some horizontal pieces on many elevations of the building where a few of those had been found to have moved a little bit. So some pretty extensive work was done to expose the connections behind the walls and then put new reinforcing in there. So the goal of this whole thing was to, look at those issues in a holistic kind of a view. And have a plan that looks at those, really looking at safety as the primary thing, longevity, so finding something that's not a thing here, a thing there, but rather a holistic plan, dealing with the feasibility of doing this, and then obviously the cost becomes important. So that's why we're going to talk about these three different, those are the things we've studied, and then we're going to talk about the three options of repairing, replacing, and then a combination of those as well. So we talk more about some of our observations.
So just to get people oriented, these are two aerial views of the school, and it's not really these colors, which you probably know. So we made a diagram to identify the different types of panels around. So the blue color was not really a problem. This is the stone, and so that requires ongoing maintenance, some of the same issues that Rocky was talking about on the church, but they weren't having the major structural concerns about those areas. The other four colors, though, were all this precast type of construction. So we wanted to look more in depth at that. And then also just to note, not necessarily the precast, but just the external wall, the envelope of the school. In addition to the precast issues, the standards for how to insulate buildings has gotten better over the years, so these are not up to current best practice in terms of standards. And then the windows of the building, many of them are original, if not all of them are original to the building, and windows have a lifespan. The seals start to wear out. Windows nowadays have double pane instead of single pane, so those are some other just underlying issues that we observed architecturally related to the facade. So just briefly wanted to show you, because Eileen's going to talk a little bit more about what we found with the different types of panels, so just wanted to give you a brief overview. So one of the main types of panels are these panels that are at the classrooms. We call them the horizontal panels. So actually from these red lines, it's one panel. So the waves is 3 waves. This is one big panel. It spans the entire classroom. And there's one at each level, the roof, the second floor, and the first floor. This is from one of the repair projects that Eileen talked about, where one of these classrooms was taken apart at the wall to investigate, and that actually provided a lot of helpful information to our study as well as on the right is a snip from one of the old original blueprints from the 1960s, so we looked very carefully at all the old original drawings. One thing to note on these panels is that in addition to it being the precast, inside of it there are pipes that supply the heat to the heaters that are against the wall, supply the hot water to those, in this repair that was done, one of the good things that was learned was that the panels could be repaired without having to tear apart the whole heating system. And not only that, the interior millwork, the cabinetry and things, could actually be disassembled and then reassembled back. So you don't have to destroy the interior to get to the connection points that's needed for these panels. So that was a really helpful lesson learned from the study, from the repair projects that have been done. The second type of panel, we call them the vertical panels. They're 2 stories tall, and these are typically on the east-facing wall at the parking lot, and there's another section just south of that that kind of faces the playground. And just inside of these walls is the corridors that serve the classrooms. There's another area in the building, in these diagrams they're represented by the red. So there's another area on the street facade that is at the library and the office area. So these panels are different. They are very tall, and they're very thin. They're actually only 4 inches thick. Eileen's we'll talk a little bit about what some of the issues we saw with this. These, however, to replace these panels or do things to these does involve a little bit more invasive work. The heaters do have to be pretty much removed to get to things, and the finishes you'll see on the inside, if you walk around the school, have been damaged some from some of the movement because they're actually just adhered right to the inside face of those panels. In most cases, the office is a little exception. And then there are a couple of other panels that don't occur as frequently, but the north wall of the gym has a unique type of panel, and then the stairwells themselves have another type of panel. So, let's see, Eileen, I'll give it back to you to talk about some of what you saw
Yeah.
in each of those.
So I'm going to talk some about each of those kinds of panels and what we saw structurally happening with each of those. So I'll start with the gym walls. So again, remember the east gym wall was replaced. I happened to be out here looking at that wall in 2014, and I found this picture recently from when I was out there. So if you see this difference of this surface versus that surface, that's what that east wall looked like. It was bowed out some, it was pulled away from the wall a little bit, and that's why that those panels needed to be addressed and be taken down. One of the key things we wanted to look at was that happening on the north wall of the gym also, because it's similar kinds of panels, and I didn't see any evidence of that at all. So that was a really good thing. There are some spot things going on there, like minor little things, but the structural stability of those, they don't have any of the same conditions going on as the east wall did. So that was a really good piece of news. If I talk about the horizontal panels now, so again, that's the peach kind of color up there on those elevations. These are the ones where, in a couple classrooms, there were some connections that were, exposed and reinforced in the past. At this point, we didn't see any signs of additional movement of those. There was a crack gauge, which is this thing over there, that was put on a number of years ago, and there wasn't signs of that moving, and the caulk hasn't pulled. There's a variety of signs that you kind of look for when you do this, and those weren't really showing up. So those were looking to be in good shape as well. The vertical panels had the most problems that we saw. So again, those are the ones that are in red on the diagram. Again, the one overlooking the parking lot already has this piece of steel there. You can see, I think you can see on these pictures here, you can kind of see, and if you go through the hallways, you can see this happening of some cracks happening around the perimeters of the walls in those hallways, and that's a sign of those panels kind of pulling away a little bit at that second floor level. So on the side overlooking the parking lot, we have the steel piece there to keep it there. We did find more of those that movement in the library area and the office area. So like this picture right here, this is a window, and so the window is set in the plane with the concrete. And then this over here is the wall that sits inside of that. And those two aren't directly connected, they're sitting next to each other. And you can see how much it's pulled away, those two things have pulled. You can also see just in this elevation picture there, you can see kind of the shadow line is a good indication there that you've got this movement happening there. So what we ended up doing was saying, this is not one that we want to let sit and wait on this. Let's do some stabilization just to be extra sure that everything is safe. So over winter break this year, we came in and put in some stabilizing bolts. So this was actually, because of that area and the access, it was a fairly straightforward thing to do. We were able to actually just drill some holes through the panels and through a beam that's sitting inside, the steel beam that's right inside of that, and just bolt the two together. It doesn't pull anything back, it just holds it all in place. And that's really what we're trying to do with that, is just keep it there, so if something wants to move at all, it's got something extra to hold it in place. So now those are very stable, and I have no concerns about those at all. So I'm going to let Eric talk for a little bit now about some of the other miscellaneous water penetrating types of things. So.
Thank you, Eileen. I'm Eric Vratz. I'm the building enclosure consultant, and I'm going to talk about, Eileen talked about some of the structural things, and deficiencies and repairs that were done with the panels. I'm going to talk more about kind of the integrity of the panels themselves and some of the common deficiencies that were noted as we did our survey about the building. Some of the main things to note is that the items that we noted as deficiencies are superficial things, they're not sacrificial. They're in relatively good condition. With some minor repairs, we can restore them to good condition, and they can be kept for a number of years. One of the number one things that I found was that the sealant joints throughout the entire elevations of the school are in a failed condition. Failed sealant joints allow for moisture infiltration, and that leads us to the next deficiency, which is concrete spalls. So when water and moisture get into the concrete via the sealant joints, it penetrates the porous concrete, and the moisture as it gets to the, as Eileen talked about, there's some reinforcing steel within the concrete panels. When water gets to the concrete panels, or to the steel rebar, obviously water and steel don't mix, so you get corrosion. So as the steel corrodes from the moisture, steel expands, and when it expands, that force has to go somewhere, and concrete as a rigid material can't take that much stress, so it cracks. So when the concrete cracks, that's a spall, and it causes the concrete to flake off, or in patches or in small amounts. So that was another common deficiency with some spalls. There's two types. One of them is in the field of the panels. The other one is at the edges of the panels. Another deficiency that we noted on the north elevation of the gymnasium, there's some grout pockets at the base of some columns that have spalled and require some repair. And then we also noted some minor masonry damage to the site screen on the west elevation of the school near the entrance. So this is a common panel edge spall. Here you can see that the concrete has come out. This is a panel joint. In here is sealant. Here you can see a little bit of the sealant, and then some sealant missing, and then more sealant. So when the sealant and the concrete fall out of there, you can see some of the reinforcing bar within the concrete panel is exposed there. I'll talk a little bit more in a little bit about how we can repair that. Here's another edge spall. The sealant joint is still in place. However, water and moisture has gotten into that panel and caused it to crack. And then there's another one here on the far northeast corner of the building where the land and stone masonry is. I apologize, that one's a little bit harder to see because of the screen. This one's a little bit hard to see, but if you can focus right here, this is a spall in the middle of a panel. This is on that same corner where that crack was at the edge of the panel. This is actually coming out. What we usually do to find a type of spall like this is a technique called sounding, where we take a masonry hammer and we tap it against the concrete, and as we go across it, we listen for a ring or like a howl sound, and if it's howl, that means that it's not intact. So we went across and did some of that. Eileen and I had gotten up in a JLG lift and went across the north elevation of the gymnasium, the east elevation of the school, and the entire west elevation of the school. This is a good picture of failed sealant joints. This is a sealant joint just above the masonry site screen on the west elevation. This happens to be a mechanical intake, but as you can see, this is about a 1.5 inch sealant joint, and there's a lot of what we call adhesive failure. In sealant joints, there's cohesive failure and adhesive failure. Cohesive is when the actual material starts falling apart. Adhesive failure is when it debonds from the substrate. This one here is another adhesive failure of a sealant joint. It's coming away from the one side of the panel. These are the grout pockets that I was talking about. These grout pockets are at the base of columns, and there's a base plate on the bottom of the columns. A lot of this is easily repairable. This is typically due to moisture infiltration, and also what promotes some of the corrosion is the salts that we use to de-ice the pavement. So when you mix the salt and the water together, it gets into those things real easily. As I said, I'll be talking a little bit more a little bit later about the way to repair these things. And these are some pictures of the masonry deficiencies that were noted on the site screen on the west elevation. There you can see one of them's cracked. Here there's a number of displaced stones. This was just one of the small things we noted, there wasn't anything, we just happened to be there, so we noted it. With that, I will turn it over to Eileen to start the discussion on the alternatives.
I'm going to start us off talking about the alternatives. So again, we talked about 3 different things. We'll talk about each one of these in more detail. But the first one was to repair what's there, keep everything that's there, repair it in place, get it into a good condition, and move on. A second was a wholesale replacement of the facade, and then the third is really a combination of those two, trying to kind of find the best bang for your buck type of a thing. So I'm going to talk about the structural repairs, because really alternative 1 is really, it's a structural project with some facilitating other pieces to it. But essentially we'd be looking at for the horizontal panels, so the peach panels up there, those are the ones that have had problems, but we're not seeing issues right now. I feel pretty strongly that we should proactively go in and address those connections at the second floor level. The second floor level is where we've seen problems with them before. They have, in particularly the conditions of the loads and all that sort of thing that I won't bore you with, but they have to work harder, basically, than the roof panels and the first floor panels. So I think that it's important from a safety perspective to go in and take care of those. Then I also think that we should do a visual review of some of them at the roof level and the first floor level. Mostly because without seeing it, we can't really know if something's going on back there. So I think it's worth taking up some of the roofing materials, looking at them, inspecting them, and if it looks great, we just put it all back. If it doesn't, then we repair those. And in the budget numbers that you're going to see, we've included a decent contingency to do that kind of work and to repair a number of them if we find that there are problems. This, by the way, this right here is that connection that in those areas that we did those repairs have been done. The silver over there, that's the original connection that was there, and the red next to it is the reinforcing connection. So you can just kind of see how, there are a lot of engineering reasons why one's small and one's big, but you can also just kind of see from a bulk perspective, like it's a much stronger connection that we're going back with, and that's a helpful thing. So. The vertical panels, so the red panels, I think we just need to go through and add new connections at the center line, so the second floor level of each one of those. So like where we put those bolts through at the library and where that steel piece is going across at the overlooking the parking lot, and then the third area, go in and put a permanent kind of solution at that location to keep those in good shape. And then also expose some of the connections at the roof. We don't see any problems with those, but again, with the history of things, we think it's well worth exposing some of them, repairing them if needed, or letting them be if they look like they're in good shape. And then the gym and stairwells, which are the yellow and green, there aren't any structural repairs that I would recommend at this point. You're not seeing problems with them. I think we just leave them alone. There are superficial things that Eric's talked about that should be repaired, and all of these to keep water out and that sort of thing. But that's really the bulk of what should be done. Eric, do you want to talk about?
Yeah, I can tell you. So talking about the small repairs, what we would do is we would cut out the loose concrete, and then we would go back and create a design to lock a patch in place, and we would try to match the original aggregate textured surface as close as possible. The other thing, we would go back and we would cut out all the sealant joints from the perimeters of the panels around the windows. That will also coincide with one of the other alternatives later with windows. And then we will also, some of the panel joints are very small, they're very tight, and some of them a little bigger. The smaller ones will route out and make them a little bit bigger so that the sealant is designed to do the job that it's supposed to. And then we will either seal or coat the exterior of the panels. What that does is it prevents moisture infiltration, and it prevents the moisture from coming in contact with the rebar and causing it to corrode and expand it and spall or pop off the concrete. And this prolongs the service life of the panels by protecting it from moisture infiltration. and I'll just show you some examples of what we're talking about. So this is a brick wall that's experienced some moisture infiltration, and what they did on this wall is they applied a protective waterproof sealer. It's a siloxane or silane coating, and essentially it's what they use on stamped concrete or any type of concrete for that matter. And you can see the difference here is that this isn't protected with sealer where this is, and the water beads up on top of it. So the panels would be sprayed with the sealer, and then it would allow the water not to get into the pores of the concrete. This is another project that we had, similar aggregate surface precast concrete panels that were experiencing some severe spalling. So what we did, and it's very hard to see, and I apologize, it might be easier to see when the presentation is loaded on your website, that we came back and we removed all the loose aggregate, and then we went back with a patch and we tried to match it as close as possible. And it looked very similar, except it stood out a little bit, but then we went over the top of it with the protective coating.
So I wanted to just fill in the pieces a little bit so you understand the scope of the work when you see the cost estimating for some of this, just so you understand why things cost a lot. So the fixes are fairly simple and straightforward to understand how they're done, but the connections that need to get reinforced are buried in the wall. So like I mentioned before, the test cases that have been done showed that it can be done, taken apart and put back together, but it does involve quite a bit of work to go into each classroom, take apart everything that's on the wall there, expose the connections. They actually have to saw cut a topping slab out of the way to expose the connections, and they'd be reinforced, and then everything is put back together. The Building and Grounds Committee worked with us in developing the scope of work and the cost estimating to make plans to take advantage of when things are taken apart, to do a couple of other really good things, like in the classrooms, there's no electrical outlets on those exterior walls right now, the way they were designed, which makes it very hard to put a window unit or do other things there. So while it's taken apart, that's the perfect time, very cheap, go ahead and put in some electrical conduit, bury it in the wall when you're putting back, so now things can be added there. Likewise, in order to not have to take everything apart again in the future, if you want to inspect these connections 20 years from now, why not put some access panels in some places? So we built in some things like that that make sense and are great ideas to make this a long life for the building. This is inside the vertical panels. Again, to get to these connections, fortunately on a lot of these, they're actually not, the connections that are the problem ones are fairly easy to get to. They're above the ceiling. I can't remember if I have a photo here or not. I think it might have been an earlier slide. They're above the ceiling, but you can get to them. But then after they're fixed, the interior finishes have cracked and are in bad shape. So there's budgeted to come and replace a lot of the deteriorated finishes that are inside these areas here. So what does all that boil down to? So this is alternative one, which is the repair connection. It's the most economical of the alternatives. However, it's not cheap. So our recommended budget is just over $1.5 million to take care of all those conditions around the school. Now that would be including everything that needs to happen, which there's some hazardous material abatement that needs to happen. Some of the fireproofing has asbestos in it, needs to be removed to be able to get to some of the connections. That would include all the construction costs, some of the contingency amounts that Eileen was talking about, which may or may not have to be fully spent, but they're included in the budget so that the money's there when you, as you're uncovering and making sure that there's not any other hidden conditions. And then as well, there's some additional design work that needs to be done, so more engineering to work out all the details to allow this to be bid. So that figure includes all of that. It's based on, we have to pick because everybody knows that costs go up over time, so we have to pick a date to base these on. So this is based on next summer. If the time were different, then the cost would be adjusted, but that's what this is based on. The good thing about this option is that it's a relatively short duration of actual work on time. With the proper planning, it could be accomplished in a summer, 10 weeks could be accomplished in a summer, so it wouldn't have to impact the school year. So that's alternative one. That's probably the most long-winded of the alternatives because it has the most details. So we want to briefly show you the other alternatives, and my colleague Jim Kawani, one of our other architects, is going to walk you through alternative 2, which is the replacement, the left side. Yes. No, yep.
So the replacement option, how do we go about this? What's an approach to putting a new facade on a school? We really studied the drawings for the school and got a sense of what the designers did here. And we work in a lot of schools, and this is a very nice building. So we were impressed with the layout of the school. Is very, it offers kind of wings of light for the classrooms. It brings light into the hallways, which is unusual. It's a nice building. So with that in mind, we looked at these facades, and this is one of those wings of light that actually broke the site down into two spaces, one a parking lot and then this nice sunny courtyard for a play yard. But you see the kind of vertical facade panels there and the horizontal there. And as we looked at these, we realized that these were precast, but they had done things to make them more visually interesting. The coloration in the panels was pretty unique, we thought, and the panels and the horizontal location were slightly beveled to give some surface articulation to them, and then the ribbon windows provided just really nice daylight for all the classrooms. And those were broken down into smaller panes as well of operable windows to provide some natural ventilation. So we decided that the best thing would be to look at new systems, but to take that under advisement as something to reinterpret what you have there. So this shows those vertical panels that Eileen talked about, and if we were to take those off, there would be wide open floors. So what do you go back with? Well, there are new systems now, new construction technologies that would provide an insulated wall. It would probably be an insulated steel stud wall, and then there are new systems for covering that, and it's called a rain screen system that sheds water. But there are cement panels, lightweight modular cement panels that could be patterned in a similar way and put together in a similar way to kind of reflect the design intent of the original architects. Again, the windows would remain. Maybe they would be bigger. They could be bigger. The modules might make the number of them different, but essentially that's what we looked at here as a way to deal with the vertical panels. And color is something that can get refined, and they're offered in all different colors. For the street facade, I guess I went 2 spaces.
That's too fast. There we go.
Yeah, for the street facade, again, we have vertical panels in the middle, so that same system of the modular lightweight concrete panels was what we were looking at. For the horizontal panels, you see these slight beveling of the long horizontals actually act in the sun to give you kind of a shaded side and a sunlit side. So there's a scale to that facade that is respectful of, you know, the residential neighborhood across the street, and deferential to, obviously, to the church on the corner. So what we tried to do with that was this whole thing would come off. All of these panels, again, would be wide open classroom, open to the air. So that would be replaced with a curtain wall, which is essentially a metal system that has panels. Some are opaque and insulated and made of metal and can be in any color, and some are obviously windows, glazed. And so the glazing pattern just follows the ribbon window pattern you have in the school. Now the small windows are also a part of it, operable windows with bug screens this time. And over the entry, we use that modular cement panel system on an insulated wall and retain the window opening. So that was our approach. We felt it was a reinterpretation of the original architect's vision for the school, and that was what was priced.
So just to recap what, quickly what this option was, alternative 2, the replacement. So at all the red and the peach facades, total replacement, the 2 different types of walls that Jim just outlined. At the gym and the east walls, which are the gym north wall, the yellow, and then the green, those would also get repaired in the same way that they did it in option 1, but not replaced, because those were not of concern. So this would be a more extensive project, and so the cost estimating, you can see bore that out. So 4.2 million for this scope of work. The rest of this text is the same as in option 1, includes all the same type things. However, the on-site amount of work is more. So at 16 weeks, that's more than a typical summer break. So that's going to encroach into the school year on one side or the other, or perhaps be broken into 2 summers or something like that. So it would be a more involved project and a more expensive project. So then we took a step back. We're getting near the end here, so almost done. We took a step back and said, what are the best things out of both of those approaches, and what could be possibly combined? So obviously one of the things on the first approach is that it's less expensive, less invasive, takes advantage of a lot of what you have already. So alternative 3 says, let's keep the existing panels and make the repairs like we did in alternative 1. However, one of the really good things about alternative 2 was getting new windows. The existing windows are really past their useful life. They don't have bug screens. They don't keep the warmth in very well in the wintertime. So we said, what if we, for alternative 3, let's price out making all the structural repairs, all the water intrusion repairs and sealant repairs to the panels, but then let's replace the windows. So when we do that, this is a view of the west side, which unless you are looking really closely, you might not know that it's actually a little different. So these have new windows. The look of the existing building would be preserved, but cleaned up, fully stabilized, and fully sealed up, new windows. So it would be basically freshening up what you have. You might not have caught it, but when Eric was talking about different approaches to keeping the water out, one was a transparent sealant coating, which is what this shows. Another alternative, let's see, actually this is the west side, the east side, I'm sorry, same thing. Then another alternative on the west would be to put on the actual coating, which was more of an opaque coating, looks kind of like a paint. So with that, it's again looks quite similar, but you don't see the aggregate texture quite as much. So it's just a different type of product. It has a longer longevity, but it's opaque. It's a little different type product, so it changes the look a little bit. And similar approach on the east side. So when we look at all that, estimates came in at 1.9 million for that one, so just under 2 million. So this alternative, feel like takes a good combination of the two. And likewise, the duration is kind of in the middle, so 13 weeks. Right at about a normal summer break. So if everything was planned and orchestrated well, it could conceivably happen during the summer break. So that's pretty much the end of where we are. Wanted to just recap. Alternative 1 was a repair approach, a little over $1.5 million, 10 weeks of on-site construction. Alternative 2 was a replacement, much larger project, 4.2 million, needed 16 weeks of on-site construction. And then alternative 3, which takes the repair plus the new windows, just under 2 million in 13 weeks. And that's the end of our presentation. I'm going to get the lights again, Brian, in case we have any questions. Or thanks for staying awake, everyone.
Joe Architects. Again, the windows would remain. Maybe they would be bigger. They could be bigger. The modules might make the number of them different, but essentially that's what we looked at here as a way to deal with the vertical panels. And color is something that can get refined, and they're offered in all different colors. For the street facade, I guess I went 2 spaces somehow.
Goes too fast. There we go.
Yeah, for the street facade, again, we have vertical panels in the middle, so that same system of the modular lightweight concrete panels was what we were looking at. For the horizontal panels, you see this slight beveling of the long horizontals actually act in the sun to give you kind of a shaded side and a sunlit side. So there's a scale to that facade that is respectful of the residential neighborhood across the street, and deferential to obviously to the church on the corner. So what we tried to do with that was this whole thing would come off. All of these panels, again, it would be wide open classroom, open to the air. So that would be replaced with a curtain wall, which is essentially a metal system that has panels. Some are opaque and insulated and made of metal and can be in any color, and some are obviously windows, glazed. And so the glazing pattern just follows the ribbon window pattern you have in the school. Now the small windows are also a part of it, operable windows with bug screens this time. And over the entry, we use that modular cement panel system on an insulated wall and retain the window opening. So that was our approach. We felt it was a reinterpretation of the original architect's vision for the school, and that was what was priced.
So just to recap what quickly what this option was, alternative 2, the replacement. So at all the red and the peach facades, total replacement, the 2 different types of walls that Jim just outlined. At the gym and the east walls, which are the gym north wall, the yellow, and then the green, those would also get repaired in the same way that they did it in option 1, but not replaced because those were not of concern. So this would be a more extensive project. And so the cost estimating, you can see, bore that out. So 4.2 million for this scope of work. The rest of this text is the same as in option 1, includes all the same type things. However, the on-site amount of work is more. So at 16 weeks, that's more than a typical summer break. So that's going to encroach into the school year on one side or the other, or perhaps be broken into 2 summers or something like that. So it would be a more involved project and a more expensive project. So then we took a step back. We're getting near the end here, so almost done. We took a step back and said, what are the best things out of both of those approaches, and what could be possibly combined? So obviously one of the things on the first approach is that it's less expensive, less invasive, takes advantage of a lot of what you have already. So alternative 3 says, let's keep the existing panels and make the repairs like we did in alternative 1. However, one of the really good things about alternative 2 was getting new windows. The existing windows are really past their useful life. They don't have bug screens. They don't keep the warmth in very well in the wintertime. So we said, what if we, for alternative 3, let's price out making all the structural repairs, all the water intrusion repairs and sealant repairs to the panels, but then let's replace the windows. So when we do that, this is a view of the west side, which unless you are looking really closely, you might not know that it's actually a little different. So these have new windows. So the look of the existing building would be preserved, but cleaned up, fully stabilized, and fully sealed up, new windows. So it would be basically freshening up what you have. You might not have caught it, but when Eric was talking about different approaches to keeping the water out, one was a transparent sealant coating, which is what this shows. Another alternative, let's see, actually this is the west side, the east side, I'm sorry, same thing. Then another alternative on the west would be to put on the actual coating, which was more of an opaque coating, looks kind of like a paint. So with that, it's again looks quite similar, but you don't see the aggregate texture quite as much. So it's just a different type of product. It has a longer longevity, but it's opaque. It's a little different type product, so it changes the look a little bit. And similar approach on the east side. So when we look at all that, estimates came in at 1.9 million for that one, so just under 2 million. So this alternative feel like takes a good combination of the two. And likewise, the duration is kind of in the middle, so 13 weeks. Right at about a normal summer break. So if everything was planned and orchestrated well, it could conceivably happen during the summer break. So that's pretty much the end of where we are. Wanted to just recap. Alternative 1 was a repair approach, a little over $1.5 million, 10 weeks of on-site construction. Alternative 2 was a replacement, much larger project, 4.2 million, needed 16 weeks of on-site construction. And then alternative 3, which takes the repair plus the new windows, just under 2 million in 13 weeks. And that's the end of our presentation. I'm going to get the lights again, Brian, in case we have any questions. Or thanks for staying awake, everyone.
So with all of that information, the Buildings and Grounds Committee is recommending that we proceed with alternative number 3. So alternative number 3 is taking care of all of those structural issues that we've been finding at the precast panels. It's sealing up the building envelope again. It is bringing back those caulk joints, making sure that we have everything sealed up from the exterior, and then replacing all of the windows in the school, which is going to provide us a lot better insulation than what we have right now. They're not going to be leaking. We're going to have the insect screens on all those windows. And then we would also put in empty electrical conduit for the future if we wanted to upgrade the electrical service here in the school and be able to put in window air conditioners. Because we're just not in a situation to be able to put in central air conditioning in the entire school. I don't see us really being in that type of situation anytime in the near future, but this at least would give us the tools that we would need to be able to expand our electrical service in the future and put in more window air conditioners if we needed them. Right now, it's a little bit tough the first month of the school year and the last months of the school year. The kids can sweat it out a little bit, but also with the better insulation on the windows, we wouldn't lose as much of the cool air that the teachers work so hard to get into the classrooms with their fans and turning the lights off. We would be retaining the blinds that were purchased a few years back, which also provide, some coverage basically for reflecting the sunlight out of the classrooms. And then also that has been providing us with some insulation in the past. Even though the replacement option is gorgeous with that master campus restoration plan that we have and all the other needs throughout the buildings, in our parish, we really can't justify putting $4.2 million into the school alone. So we do have all of those other needs at the church with the tuck pointing, with the stained glass windows, and all of that additional work. That really this was a good balance to be able to maintain everything that we have campus-wide. So with that, I'll open it up to any questions. Yes?
What's the priority of the church or the school at this point?
So the question was, what is the priority of the church or the school? So in the restoration plan, we have prioritized the projects based off of safety concerns, needs that we felt need to be accomplished, and then really also the order in which the projects need to take place. So right now, this facade work specifically in the school is priority number 1. It's followed by tuck pointing inside of the church. And then there's some tuck pointing, and other school projects that are also included later down in the list. So there's not specifically a priority of church versus school per se. We're focused on the safety of those precast panels of the school, which is the main reason why it's the priority number 1. But that's not to say that the tuck pointing in the church is not equally important, I would say.
So you guys on the lifespan for repairs to the facade? Or do they mean, how long would they last?
Yeah, so the question was, what is the lifespan of the repairs? How long would they last? So one of the things that we are going to do when we're proceeding with the repairs, if that's the option that we move forward with, is we're actually going to work with the engineers and architects to develop a ongoing maintenance plan. So actually getting on top of those sealants when we reach the expected useful life of them and getting in there and replacing them, which we have not really done in the past, is really going to give us a lot of life on this. So there's no reason why the structural repairs wouldn't last for many, many years as long as we keep the moisture out. So that's the big thing, is making sure that we continue with maintenance, routine maintenance. I would say for a lot of sealant projects that we probably would be able to get maybe 7 to 10 years before we have to start considering doing a little bit of maintenance, but it's going to be a lot cheaper than anything that we're having to do right now.
7 to 10 years before maintenance would need to happen?
Correct.
As in the maintenance would continue to preserve the life of repaired facade?
Correct.
And I think when she talks about maintenance, it starts with an annual inspection of what deficiencies exist. And there might not be any sealant repairs needed at that 5 to 7 year mark. But that's a good idea to look into the future at the 5 to 7 year mark.
Yeah, so if everything is working great, if it's on a side of the building that really doesn't have like a lot of weathering and direct sunlight, those really break down those materials fast, and we don't need to replace the sealants, then we won't. But at least then we'll have it built into our budget to take a look at it and replace it if it needs to be taken care of. And the sealants are, again, relatively very cheap compared to the structural repairs that we would need to do right now.
You said you probably went to school this year because of just the time constraint. Are you starting a church first, or what's the plan when you start?
Yeah, so the question is when would all of these projects start? We actually would need to retain an engineering and architecture firm to perform all of the design if we proceed with alternative number 3. So we would procure that company and get that contract rolling this year, get the contractor on board sometime this winter with construction next summer on the school. Likewise with the tuck pointing on the church, we really have to see, number one, how much we are able to do. If we're able to do all of the walls of the church at one time, or if maybe we have to break it up and do a portion of the church and kind of take it piecemeal in order to make it a little bit easier. We are going to have to, basically rent that scaffolding and move it around. So we're going to have to work with a few different things. So I would say that construction primarily would be starting in 2024 at this point. Well, if there's no other questions, thank you for coming tonight. I really appreciate it. If you think of anything else, I'm in the Buzz Book. You can give me a call or email me anytime, and I'm happy to answer questions. Thank you.